So today for this video, you are going to need a periodic table and a calculator. We are talking about percent composition. It's pretty easy, but you never know. All right, so let's get started. So when we're finding the percent composition, we are finding the percent by mass. Oh, I'm on the wrong type of markup. Percent by mass of elements. And so basically what we're going to do is we are going to compare the mass of the element to the mass of the entire compound. So to find percent composition, it's mass of the element you're looking for divided by mass of the total compound. So yeah, that's pretty much it. Mass of the element divided by mass of the compound. So let's go through our steps. So step one, you need to write the correct formula for the compound. So this goes back to using our naming rules. Is it ionic or covalent, swap, drop, reduce, all of that fun stuff. And then we are going to find the molar mass of the entire compound. So to do that, we add up all of our masses from the periodic table and multiply them by the subscripts, all that fun stuff. And then you'll divide the total mass of the element in the compound by the total mass of the entire compound. Multiply the result by 100 to convert it to a percentage. And since this is a percentage problem and percentages don't really have sig figs the way we traditionally have them, we always are going to express our answer to 2 decimal places with a percent as our units. All right, so let's dive in to our first problem here. All right, and it wants to know what is the complete percentage composition by mass of potassium dichromate. So anytime it asks for complete, we are looking for all the elements. We are looking for all the elements. All right, so let's look at potassium dichromate. Ends in an 8. All right, it's an ionic compound because potassium is a metal. Ends in an 8, so that is one of our polyatomic ions. So it is an ionic compound. So potassium is K. And it's in group 1, so it's a positive 1 charge. And then dichromate is Cr2O7 with a negative 2 charge. Swap, drop, reduce. And we get our formula as, I'm going to zoom in a little bit, K2Cr2O7. All right, so first thing we need to do is we need to solve for the molar mass. And I'm going to come do that over here. All right, so starting with potassium. So potassium is, there's 2 potassiums in my formula because of that subscript there. And for each potassium, I'm going to add its mass twice. And so from my periodic table, the mass of potassium is 39.10. And I just got that number straight from the bottom of my periodic table. Right there. That's potassium's mass. So 31.10. And then I have chromium. Chromium is Cr. And I have 2 chromiums. And the mass of each chromium from my periodic table is 52. And then finally, my last element that I have is oxygen. And oxygen is O. I have 7 oxygens in my formula, so I have a total of, and each oxygen's mass would be 16. All right, so then if I kind of solve this, so I have 2 times 39.10, that gives me 78.20 for my mass of my potassium, and then 2 times 52 gives me 104, and then 7 times 16 gives me 112.0. Add all of our masses together, and I end up with 294.20 as my total molar mass of potassium dichromate. All right, so now we want to find the complete percentage by mass. So we are going to just find the percentage of every single element. So I'm just going to go in order of my compound, and I'm going to start with my percentage of potassium. So my percent potassium. And so first thing is going to be the mass of my potassium. So in this case, I have 2 potassiums, each with a mass of 39.10. And so my total mass of my potassium in this compound is 78.20. And again, we just got that from right here. We have 2 potassiums, each with a mass of 39.10. So that gives us a total mass for our potassium of 78.2. Divided by the total molar mass of my compound, which we just solved for, and our total molar mass is 294.20 times 100, and then just plug it into your calculator. So 78.2 divided by 294.2 times 100, and we'll round it to 2 decimal places. So I got 26.58%. All right, and that's our percentage for our potassium. Okay, now then let's do our next element. So our next element would be chromium. So percent chromium. Then, all right, and we have 2 chromiums in our formula. Each chromium has a mass of 52. So we have a total mass of chromium of 104 grams of chromium divided by our total molar mass, which is 294.20 times 100, because this is a percent problem. And then we'll plug it in. So 104 divided by 294.20 times 100 gives us, round to 2 decimal places, gives us 35.35% for our percentage of chromium. And last but certainly not least, our last element that we have here is oxygen. So now we're going to solve for our percent oxygen. And we had 7 oxygens, each with a molar mass of 16, and we solved it over here. 7 times 16 gives us a total mass of oxygen of 112 grams of oxygen, divided by our total molar mass, which is 294.20 times 100, and then just plug it on in. So 112 divided by 294.2 times 100, and round it to 2 decimal places. I got 38.07% for our oxygen. So this first one is for our, drop my pen, is our percent potassium. This one would be our percent chromium, and this last one is our percent oxygen. Okay, so it's just whatever part of your compound you're looking for, divided by the total mass. All right, let's do our next one. Okay, so for our next problem, it says, what is the percentage of calcium in calcium phosphide? So this time we're just finding it for a single element instead of for the whole compound there. All right, so we have calcium phosphide. So first step is to write out our formula. So calcium is Ca with a +2 charge. It is a metal, so we do have an ionic compound. We have phosphide. It ends in that "ide" right there. So that "ide" tells me that it is just a single normal element. It's not a polyatomic ion. So that is P, and phosphorus is in the group 15, so it has a -3 charge. So when we swap, drop, reduce, we end up with Ca3P2. Okay, our next step is to find the total molar mass of our compound. All right, so let's start with our calcium. And in my compound, I have 3 calciums. And from our periodic table, calcium has a charge of 40.08. And then we have phosphorus, and I have 2 phosphoruses, and each phosphorus from my periodic table has a charge of 30.97. So right here, my total charge of my calcium, total mass of my calciums is 3 times 40.08, gives me a total mass of 120.2. And then my total mass of my phosphorus is 2 times 30.97, gives us 61.94. So then add them together to get our total molar mass, and we get 182.14 grams per mole. Okay, And this time it wanted to know what is the percentage of calcium. So we're just going to solve for 1. So we want to know percent calcium. So it's going to be the mass of our calcium. So once again, the total mass of our calcium is 120.2 divided by our total mass. So our total mass here was 182.14. So then plug it on into our calculator. So 120.2 divided by 182.14 times 100, and we'll keep 2 decimal places there. So I got 66.00%. Oh, wait, no, I'm sorry. 65. I got a little excited in my rounding. 65.99%. All right. There we go. All right. So now I'm going to show you guys a slightly different problem, and this one will be more about how we use percent composition outside of just like these kinds of questions. All right. So right here, it wants to know how many grams of calcium are present in 156.8 grams of chalk, calcium carbonate. So we can actually use our percent composition to help us figure out a problem like this. All right. So step 1, we need to, when we see this problem, we want to know how much calcium is in there. Well, I can just multiply it by the percentage of calcium to figure out how much calcium would be in that sample. All right. So step 1 is we need to figure out our formula. So calcium carbonate, I have calcium and it has a positive 2 charge. And I have carbonate, which is CO3 with a negative 2 charge. So I swap, drop, reduce, and I end up with CaCO3 as my formula, since those both would cancel out. Okay, now I'm going to solve for my percent composition. So I need to solve for my molar mass to solve for my percent composition of calcium. So I'm going to solve for basically figure out the molar mass of each of my elements. So calcium, there's 1 calcium, and so calcium has a mass from our periodic table of 40.08. We have carbon, and once again, we only have 1 carbon, and that would have a mass of 12.01 grams. Then finally, last but certainly not least, we have oxygen. I have 3 oxygens, and each oxygen has a mass of 16 grams. So we'd add our mass all together right there, and I would end up with 100.09 as my molar mass of calcium carbonate. Okay, and then I want to know how many grams of calcium there are, so I'm going to want to figure out the percentage of calcium in my compound. All right, so percent calcium is going to be the mass of calcium divided by my total molar mass. So there's only 1 calcium in my compound, and calcium has a mass of 40.08 divided by the total mass of my compound, which is 100.09 times 100, and then plug it in. So I end up with 40.08 divided by 100.09 times 100, and I got that that calcium carbonate is 40.04% calcium. Okay, so that means that my compound is made up of 40% calcium. So by mass, so if I have 156.8 grams of chalk there, then 40.04% of it is going to be calcium. So to figure out how much it is, I can say 156.8, and I know that 40.04% of it is calcium. Well, anytime we're multiplying percentages, we have to convert them into a decimal. So I'm going to do 156. Let me make sure I write the number right. 156.8 times 0.404 is going to give us our mass of calcium there. And so we'll multiply it in, plug it into our calculator on 156.8 times 0.4004 gives us 62.2 0.78 grams of calcium. Okay, guys, so I want you guys to go ahead and pause the video and work this next problem. All right, so pause now and work the next problem. Okay, guys, hopefully you worked out the problem. So I'm going to work through it, kind of talk through it now with you guys. So step 1 is to solve the total for the total molar mass. So we had 2 aluminums and 3 oxygens, add them all together, and we ended up with a total molar mass of 101.96. Then I found the percentage of aluminum. So our total mass of aluminum in our compound was 53.96. divided by our total molar mass, and that gave me 52.92%. Now then, we have a 34.5 gram sample of aluminum oxide, so we needed to figure out what 52.92% of 34.5 is, multiply them together, and you should get 18.26 grams of aluminum could be recovered. All right, we have one more problem to work through now, and then we're done. All right, so this one is slightly different. So this one says, a chemist determined that 1.26 grams of iron reacts with 0.54 grams of oxygen to form rust. What is the percentage composition of each element in the new compound? Okay, guys, so what you need to know is that mass is neither created nor destroyed. So whatever mass you're starting with is the mass that we're going to end with as well. All right, so if I have 1.26 grams of iron in my starting compound, I'm going to end with 1.26 grams of iron. And then if I had 0.54 grams of oxygen, I'm going to end with 0.54 grams of oxygen. So the total mass of my new compound should be 1.80, which is just adding those two together. Because whatever I start with should be what I ended with. All right, and it also says that that's the mass we needed to react. So now we can figure out our percentage of each element. All right, it's just going to be the same, but instead of using our molar masses, we're using the masses that were given to us in the problem. All right, so starting with our first one, so our percent, and I'm just going to go with iron. All right, my mass of my iron from my problem is that I have 1.26 grams. Divided by the total mass of my compound, which is 1.80, times 100. And then we'll plug it on in. So 1.26 divided by 1.80. Oops, I plugged it in the wrong way. Times 100, and I got straight up 70%. All right, and then we'll do the same thing with our percent oxygen. So we got 0.54 grams divided by 1.80 grams times 100. And we should get 30% oxygen. So then we'd have 70% iron and 30% oxygen. Okay, guys, that's it. That's percent comp. So hopefully you're feeling okay about it. Feel free to reach out to your teacher if you have any questions. All right, bye.